Yes guys, you can refer your lecture notes for this and find out what is the damping coefficient.
Sir, this chapter I am
Okay.
not confident. Please go ahead.
Okay, no worries. So let's check the answer. So correct answer is the damping factor. So you have been asked, you need to calculate the damping coefficient in a given case to the critical damping coefficient. So let's say in a certain case, so you are having a damping coefficient C, and then the critical damping coefficient is given by CCR. So the ratio of that corresponding ratios is known as the damping coefficient. So damping factor. So this is the correct answer, option C. So Xi is equal to C by CCL. Then you have been asked like which are the parameters required in the analysis using mass spring dashboard model. So mass spring dashboard model is like, let's say if you are having a certain system, then this is usually being operated by a single degree of freedom system in which, let's say, this particular body is having mass, and then you assign an element which is given the material property through the stiffness, and uh, at the end you are having the fixed condition. So what all parameters are required? So you are having mass, you are having the stiffness. So this is particularly the mass spring dashport model. Okay, dashport is also there. So along with the stiffness you are having the dam damper also available, which will take into account the dissipation of the energy which is happening in the system. So this is the your mass spring dashport model. So what all parameters are required for the analysis of this type of parameter? Hello. यस सर, गुड इवनिंग. हाँ सर, वो इंस्टॉल हो गया था वो. हाँ वो लोग चले गए, उन्होंने क्लैम्प कर दिया था, मतलब जहाँ पे रिक्वायर्ड पोजीशन थी. हाँ यस सर, यस सर, अभी तो टेम्परेरी हमने मतलब. हाँ. हाँ यस सर, यस सर, मैंने अभी बोला है एक्चुअली, वो कल तक आ जाएंगे, तो वो ब्लैक पॉलीथीन जो कवर होते हैं उसी को लगा देंगे. मीन वाइल हमने जो लैब में ही कुछ क्लोज पड़े थे तो उससे कवर कर दिया था. अभी मतलब आज मतलब टेस्टिंग का. हाँ यस सर, यस सर, यस सर, यस सर, यस सर. डैक सर, मैं ये सर सूडो डायनामिक लैब से एक बार चेक करता हूँ उसको. नो प्रॉब्लम सर, मैं एक बार आज रात को प्लान करके कुछ होगा टेंटेटिवली तो आपसे डिस्कस करता हूँ कल से, पता. ठीक, ओके सर, थैंक यू. Yeah, so the correct answer is option C. So we can see you require the, so this particular dashboard system is usually being characterized by the damping ratio, which is given by Xi. Then you are having the this particular model which basically takes the stiffness into picture, this which basically take the stiffness into picture, and it is characterized by the stiffness which is given by the K, and then you are having the mass. So this is the mass. So among all these three parameters, which we are having the two parameters into picture, which is the damping ratio and the spring constant. Mass is also one of the parameter which is not included in the option, but yeah, your both option A and B are correct. So correct answer is option C. Both option A and B. So let's move to our fourth question. What do you call the maximum displacement of a vibrating system from its equilibrium position? I hope you.
For the analysis,
Hmm.
I tried doing that.
Hmm.
I like, according to me, the logic, like I finished modeling, but then I put, sorry, are you?
Yeah, it's fine.
Then I put the static analysis 3000 K wiring load. It's failing. Like it's not failing. It's everything is coming 0 0, and at the last it's saying super U error found.
Hmm. So in the monotonic loading, it's coming like this.
Static pushover.
So
Yes.
have you rectified all those three issues? Like first was when the PY liquefaction was,
Yes, yes,
and
I
third
did.
one was. Just give me a notebook.
Yeah, I did all that.
Damping. Acha, monotonic loading. So have you applied monotonic loading? It's coming out as
Static.
0 0.
Yes.
Okay, let me take the model. Can we meet after 8 if it's possible?
Okay, sir. Otherwise tomorrow.
ऑनलाइन मीट करते हैं रात को ना बिटवीन 10 11. इट्स फाइन
Yes.
राइट. सो सॉरी यार
No
एक्चुअली
problem.
आई
Sir will come. If
एम नॉट श्योर यार. Yeah, so the correct answer is option B, which is the amplitude. So let's say if you have a certain system and this system is being getting vibrated. So let's say this is the pendulum which you're having. So this is the equilibrium position. So as we know, if we give a little initial displacement to this pendulum, it will vibrate considering its natural frequency, and the maximum displacement which will it will reach from its mean position is known as amplitude. So the correct answer is B, amplitude. Okay. So this is like we have studied in our 12th standard also, so that's a similar problem. Yeah, so now come, so those were the questions related to the fundamentals related to the vibration. Now here comes the inclusion of that particular vibrational theory into geotechnical engineering. So this is the question number 5 which is there in front of you. You are having a machine foundation which basically weight 85 kilonewton and has a spring constant K equals to 11,000 kilonewton per meter. The system will be critically damped if the damping coefficient is Cc in kilonewton second per meter is. So you need to calculate the damping coefficient Cc. Yeah, so we have any answer? So your correct answer is 617.4. So usually in the case of the critically damped system, your CC is given by 2 root kn. Sorry, it's 2 root kn. So your CC is basically given by 2. Your key stiffness is, you need to take it into kilonewton per meter, and your mass also you need to take it in the kg. So here it's 85. So for conversion into mass, we need to divide it by the acceleration due to gravity, which is given by 9.81. So for the critically damped system, the damping coefficient Cc can be evaluated using this formula, and I guess this corresponding value is this. So it's basically 2 into 11,000 into 85 divided by 9.81 root over, answer it's 2 into 308.72. So your CC value is basically 607.45 kilonewton second per meter. So this is your critically damped system. Now let's move to question number 6. So if mass is equal to 3 kg, if m equals to 3 kg, mass is attached to the end of an unknown spring k, and natural frequency of the system was found to be 90 cpm, then the value of the unknown spring k in kg per meter is. So you are having a certain spring coefficient, you are having a mass, your spring constant k, and the natural frequency of the system Fn is given by 90 cpm. So the value of the unknown spring constant k you need to determine. खेलने के लिए आएगा? चलो क्लास है तो 8 बजे फ्री हूँ ना. 8 बजे तो जाना है ना, पार्टी तो फिर पार्टी में So your frequency is basically given by 90 CPM. Yeah, you can try this question. Guys, any answer? So the answer is B, 266.4. So this is a simple like vibrational problem, I think, which we have tackled in our like schooling system also. So let's say if you are having a mass attached to a spring system which is having the stiffness K, then the natural frequency of the system is usually given by omega n root over k by n, right? And your omega n is basically given by 2 pi f. Okay, so this is your mass, this is your stiffness. So due to, like, if I excite this system with a certain displacement, it will start vibrating with certain amplitude, and the vibrational frequency, the natural frequency with it will vibrate, is given by Fn 19 cpm, which is given by 90 cycles per minute. And which is also given by 90 by 60 cycles per second if we operate in our unit system. So that will be basically 1.5 cycle per second. Okay, so frequency is 1.5 cycle per second. So your first we need to evaluate the frequency, so then we need to calculate omega. So for omega it's basically 2 pi and your f is 1.5, so basically omega is given by 3 into pi. So basically it's 3 into 3.14, which is 9.42 radian per second if we see the angular frequency. And then our task is, like, we need to calculate the k value. So we know omega is given by root over k by m for a vibrating system vibrating with a certain natural frequency. So you need to evaluate k. So k is basically given by omega square m. Omega square is 9.42 square, and your mass you need to take it in kg, which is 3. So let's see this. So 9.42 square into 3 is basically your 266.2 kg per meter. So the correct answer is option B, is 266.4 kg per meter. Yeah, answer is option B. Great. So any doubt in this, guys? Okay, if not, so then let's move over to question number 7. Yeah, so it's a follow-up question. So in the previous question, let's say if I increase my mass, then what will be change in your natural frequency of the system? Guys, the data from previous question is this, so you just need to utilize this particular relation and then you need to evaluate what will be the new natural frequency. So let's say in this certain system I have increased the mass by 1 kg and the stiffness remains same, then you need to calculate how much is your natural frequency of the system.
Sir, next slide, sir.
Yeah. So let's check the answer. Answer is option D. So from previous question, we know the stiffness of the system which you got is K is equals to 266.4 kg per meter, right? And now your mass has been increased to 1 kg. So previous it was 3 and then it has been increased by 1. So your new mass is 4 kg, right? Now it's straightforward. So the natural frequency of the system omega n is your none other than K by m, and your K is 266.4 kg per meter. Your mass is 4 kg. Your answer divided by 4 root over answer is your 8.16 radian per second. Yeah, and we know omega is your 2 pi f, so f is your omega by 2 pi. are we making issue with some units? So it's your k by m, omega n is none other than kg per meter, mass will get cancelled. So your f is omega. Omega is your 266.4 divided by 4. Root of answer is your 8.16. So your f is 8.16 divided by 2 into 3.14. So that will be your natural frequency of the system. Okay, it's has been asking CPM. Okay, so we need to multiply it by 60. 2 into 3.14, it's your 1.299. That is basically your cycle per second or cycle per minute in CPM. It's your 1.299 into 60. So that will give you answer as 77.97. So the correct answer is D. Yeah. So for question number 7, correct answer is D. So that will be your 1.299 into 60 will give you a cycle per minute. Yeah. So our correct answer is option D. Any doubt in this? If not so, then let's move to question number 8. So you are having a trench which is 5 meter wide and 10 meter long, which is excavated in the medium dense sand. The side of the trench are supported with sheet pile walls fixed in a place by strut and the volley, that is a brace excavation. Assuming gamma is 18 kN per meter cube and phi is 30 degree, the maximum pressure against the sheet pile wall. Yeah. So that's a question related to the deep excavation. So you are having a certain trench available with you. The dimensions of the trench are given to you. The soil in which this trench has been laid out, that properties of the soil is also given to you. Then we are placing the sheet pile wall to resist the loading. Yeah. So what is the maximum pressure against the sheet pile wall? Yeah, so let's check the answer. It's 39. So we have added this type of questions before. So let's say you are having certain pile wall system. The trench is 5 meter wide, and this is your and the total length is 10 meter. So that is the top view which I'm talking about. So the soil which is there, so the gamma value is 18 km per meter cube. Your phi value is 30 degree. So we know the maximum pressure at the bottom against the sheet pile wall is given by your gamma HKA. So your gamma is 18 km per meter cube. Height, total height is 10 meter, right? Is it the
Into 0.65, sir.
yeah?
Gamma,
H is 10 meter, is it?
sir, which is, sir?
Your H value.
It is only K, sir, not active, passive or anything. It is only K, pressure coefficient.
No, K value is 1 by 3, right?
Yes, sir. It is correct, sir. It's correct only. Active earth pressure. 30 degrees is 1 by 3. Yeah.
And H value is 10.
H value is 10. It is not a long actually. It is a
This is a
high.
height, right? Yeah.
Yeah, height,
So,
sir. Height,
so
sir. I observed.
that's
Long is infinite actually. Trench means.
okay, okay, okay. So maybe I have written. So this total length is 10 meter. Sorry. Okay, so then this will be a 3 by 18, which is 6. So the maximum pressure in again the sheet pile wall, gamma is 18. So how much is this value?
You didn't multiply with the 0.65, sir. Because the formula is 0.65 into Ka into gamma H. Apparent pressure
Okay,
distribution
yeah.
diagram.
So that is the formula into 0.65.
0.65. Now it is okay.
Okay, we need to take only 2/3 pressure. That's why is it? It's 0.65 gamma HKA. 0.65 into gamma is 18. Your height is 10 and K value is 1 by 3. So which is none other than 39 kp. 6 into 0.65 into 10, which is 39 kp. Okay.
Why it is multiplying 0.65?
So for the apparent earth pressure, like when you are having the deep acceleration system, so the maximum acceleration it will be having this is the formula which is given for that. So I'll explain you. So the maximum pressure against the sheet pile wall. So let me open the source lectures. It's in deep acceleration.
These are the recommended values are in the pressure distribution diagram.
But how the 0.65 is coming? I want to check that.
Actually, they have not mentioned in a derivation of all these.
Mm-hmm.
They have recommended the three pressure distribution diagram. One is for sand, stiff clay, and soft clay.
Okay.
In that, they have given the variation of the pressure diagram as well as the pressure values. It's mentioned in the one of the deep excavations topic.
Yeah.
But derivation is not mentioned. How you got 0.65 or not?
Okay, they haven't mentioned the derivation.
No, sir. No, sir. These are the three cases.
Mm-hmm. So for the sandy soil, so this might be the empirical relation which they have considered. So there is no such mechanics which is basically involved which we can take into account. So okay, so they are not considering the entire strength; they are just considering the 0.65 times of that particular strength, right? So
Yes.
and then according to what stage yeah, but reason should be given. So let's say usually we are having the whole strength available for the deep excavation. So
At the bottom, something written also. You can check, sir, that apparent pressure distribution diagram.
Okay,
It is
so
recommended by Peck and somebody.
so I guess this is the particular trend which they have observed, might be in the geophysical investigation or let's say in the numerical modeling, or maybe in the code basically they are suggesting such that you should underestimate the load and underestimate the pressure which is coming from the soil. So that is how they are designing your sheet pile load. So it's not the entire pressure which is coming. So usually we are having the triangular distribution, but instead of that they have mentioned the rectangular distribution and they have reduced that distribution by a certain uh, factor by multiplying it with the 0.65. So okay, then we'll go with their formula which is 0.65 gamma HK. So this is the recommended pressure which is suggested by the one of the author pack, which is also mentioned there. So we need to go with that. So in geotech, like mostly there are things which are mechanics derived, but since the soil is very highly heterogeneous for various locations and it's having highly high variability, so the you can't apply the mechanics for a global system. So you need to derive some empirical relations for certain site, and you need to reduce strength somewhere, you need to overestimate the strength somewhere by considering the for specific cases. So that's how you need to operate it for. So for this particular specific case where you are having the deep excavation available with you, you need to see that the pressure diagram which is happening is having the rectangular distribution and it has been reduced with a factor of 0.65, and that is the particular relation you need to take into account. So the active pressure which is available is 0.65, 18 into 10, 0.65 gamma is Ka, and gamma in our case is 18, H is 10, and K is 1 by 3. So that is the 39 kP. So this is the question number 8B. So let's move to question number 9. So question number 9 and 10 are related. So you are having a certain deep excavation system available with you which is supported by a brace system. So the proposed brace excavation at the site which are the apparent pressure diagram is shown in the figure. The stairs are
Sir,
placed.
can you share it?
Oh, sorry,
Can you
my
share it?
sorry. Is it visible?
Yes, sir. Now it's okay.
Yeah. So you are having the proposed brace excavation at a site with the apparent pressure diagram is shown in the figure. The struts are spaced longitudinally at 4.4 center to center, and the sheet piles are pin or hinge at strut level B and C. So the load on strut A is बताओ।
कुछ नहीं, ऐसे है मुझे लगा क्लास खत्म हो
अरे
गई।
यार वो 8 बजे तक कल चेक
6 से 8
6 से 8 हाँ
करो करो।
आए थे सर आए थे
कितने थे?
अभी थोड़ी देर पहले मुन्नी टाक के गए फिर बोले कि बिजी हूँ बोले कि खुला है क्या लैब तो मैंने बोला कि नहीं सर अभी तो
ये लगा दिया है उन्होंने, क्लैंप भी कर दी ना?
हाँ हाँ लगा
प्रॉपर आ गया ना फिर?
आ गया आ गया था मतलब थोड़ा लेवल वगैरह चेक किया हमने तो एक बार तो 2 मीटर टाइप पे लगाया हमने उसको।
तो वो ठीक है, मतलब वो क्लैंप उनके सही बन गए और सही तरीके से
हाँ हाँ
वो
हाँ
हो
वो
गया।
कल आ गया प्रॉपर सही टाइम पे काम आ गया आज ही मतलब अच्छा था मतलब कलर भी हो गया वो भी आ गया भाई भाई कहाँ से इलेक्ट्रिसिटी उठा के ले आया
नहीं, इलेक्ट्रिसिटी तो हम ये हमेशा लाते हैं क्योंकि मेरे सारे काम ऐसे ही होते हैं।
अच्छा
जब मैं
अच्छा
कोई ज़्यादा दंगा करता हूँ तो फिर वो इलेक्ट्रिसिटी वहाँ से आती
गुड जी
है।
अच्छा
तो अभी देखो वहाँ से लगवा के वो बता रहा है, उसने हर बार ऐसे हुआ है मेरे साथ।
गुरु जी लेके चलो 10 दिन में सेटअप रेडी करो एक काम करो होता नहीं इसका दूसरा पहला होता
वो तो ये चाह रहे हैं सारे काम मेरे, ये पता नहीं ये इंसान नहीं पता नहीं क्या है, तो इनसे पूरी दिक्कत नहीं है। तो आप काम भी करवाएंगे, फिर रसोई भी कराएंगे, फिर न्यूमेरिकल भी टेस्टिंग।
है ये शिप भी करो इनकी दो दो फिर वो भी करो वो भी करो फिर इनके प्राइम कॉग्निजेंस आ जाते हैं पीछे
आगे बढ़ो तो भाई
फिर
क्या कर सकते हैं।
भाई So let's check the answer. So the correct answer is D, 396.8. So we are also given with the pressure diagram, so let's utilize that. So correct answer is 396.8. So let's say this is your acceleration system and the pressure diagram which is available to you is this. So this is your part, right? So this is your this is 0.25 h, this is 0.5 h, and this is again your 0.25 h. So this is your 0.25 gamma h. So you need to evaluate how much is the load coming on the strut A in kilonewton. So for that you need to evaluate the pressure loading at every instance. So how much is also is 396.8 kilonewton. So you have been asked on the strut A. A is located at a distance of 1.5 meter. So this is your 1.5 meter. So this value we need to evaluate. So let's say 0.25 gamma h is none other than 0.25 gamma value. Water table is not available, so gamma is 18.5. Then your h value is, what is the total height? H is 12 meter. Yeah. So this value is given by 0.25 into 18.5 into 12, which is given by 55.5 kilonewton. So load on, so this is the total weight of this system. So it's kilonewton per meter square, so it's a pressure. Then you have been asked to calculate the load on strut A. So how you guys have calculated that?
So you have to draw the diagrams are still two locations of the strut A and B.
So let's say this is my A
Yeah.
location.
Strut.
So this is will be having the triangular loading till here, right?
Yes, sir. This value of 55 is acting from right to left.
From right to left, like this.
Yeah, just like UDL, strength of materials.
Yeah. So once you have this, you need to calculate the area of this diagram, right?
Opposite directions.
Sorry. Yeah. So your left to right is different. Sorry.
Yeah, the direction.
Yeah. So that's the value. So you need to calculate the area of this pressure diagram, right? To calculate the what is the force available here, right?
No, sir. Little bit is still it's complicated actually.
Mm-hmm.
First, you locate the with another color pen. You can write the strut location.
Mm.
First, strut A location.
Yeah, so this is the strut A location, which is 1.5 meter.
Yeah. Show the arrow mark and locate the strut REA.
So I'll just extra highlight this. Okay.
Yeah.
And
And similarly, strut B also.
so your strut B is located at 3 meter.
3 meter below the strut A.
So this is 1.5 meter. Then this is your 3 meter. How much is 0.25 h? Is 4 meter, right?
That is a 4.
So it will go somewhere below.
Exactly at the end of the triangle. Still below.
Exactly at the end of the triangle.
No, it's still below. 4.5 meter, right?
Yeah, little bit, right? It's yeah,
Mm-hmm.
it will go up to here. So
That
here
is the
this is
location of strut B.
the strut B.
So we mentioned strut B is a hinged one.
Hmm.
Now
So
we take RA into 3 meter. Take a moment about the point B.
RA.
Uh, RA into.
Okay, so this is the hinge location which is available.
Mm,
So let's say if this is the hinge I'm having,
yes, that is the hinge.
and hinge and
That
strut.
point is B.
This is the
That
B.
point is B.
This is the
Uh,
point B. So you need to calculate the suppose the load on static. So this is the, let's say, the load on static.
strut is opposite, sir. Strut is opposite.
Yeah.
That is the pressure actually.
So that is the reaction you're talking about, right? So that is your RA,
Yeah.
and this is your B.
Mm.
So first, then you need to calculate the. Okay, so you need to take the moment about B, right?
Yes, sir. Take a moment about the.
Sigma and B. So now the all forces are available. So we'll be having the forces from this triangular diagram and this rectangular diagram, right?
Yeah, right hand side we have pressure, just like a strength of materials. Left hand side we have strut.
Okay. So then this is the PB P2 I can say, and then this is the P1 I can say, which is acting. So P1 is the resultant force which is acting due to this triangular pressure diagram, and P2 is the resultant force which is acting in this rectangular diagram, right?
Yes, sir.
So for calculation, so first we need to calculate P1.
Sigma MB is equal to 0.
So yeah, so P1 into how much is this distance? So it will act at 1 by third, right? So this distance is 3, so this is 0.5. So 0.5 plus 1 by 3 of
3.
3, and then you are having the P2 which is acting at 0.5 by 2, and then you are having the RA which is acting in negative direction, which is located at a distance.
3 meter.
It's exactly at 3 meter.
3 meter, yes, sir. Between RA and RB.
Yeah, so it's acting at 3 meter. So this is equal to 0, right?
Yes, sir.
So now P1 value is we need to calculate. So it is given by gamma H Ka.
This already calculated, sir. 55 kPa already calculated on the top.
Okay, so it's 0.25 gamma kh.
Hmm.
Okay, it's already calculated. So
Already calculated. UDL is acting on the right side.
okay,
Now we need to convert that one into the
okay,
55.55
55.55.
multiplied by
This value
1.5. 1.5.
1.5. So this
That's all.
55.5 is the pressure, right?
Yes, sir. Kilonewton per meter square. That is a 55.55 is a kilonewton per meter square.
Yes.
Into 1.5 is a meter.
It's a lever arm. So it's a
So
height. So this is the total force, which is
that is a kilonewton per meter
per
you will
meter.
get.
Uh,
That's
and
all. That's all.
all.
And whatever you have a moment that is same, you can copy once again. 0.5 plus 1 by 3 into 3.
So that is 3, 3. So that is again 1.5, right?
Yes, sir. Plus P2.
Plus P2 is again
P2 is a rectangular portion.
rectangular portion.
55.55
Hmm.
into 0.5, 0.5.
So that is a total height.
Total height. That's all.
And
And already you have written the moment 0.5 by 2. Already you have written on the top that you can copy once again. This is the value of P2. What you have written is P2 till now.
Yeah, got it. So minus RA into 3.
Sir, something is missed. Before RA, 55.55 into 0.5
into 0.5 into
into
0.25
0.5 by 2. 0.5 by 2. That is missing. That's correct.
minus RA by 2.
RA into 3.
So this value half should come here, right? That's a triangular diagram.
Yes, a triangular diagram already you have written, no? That is 0 plus 55 by 2. Yeah, correct. Half has to come.
Yeah, half need to come.
Yes.
Okay. So we need to take the area of this diagram and then we need to multiply it. So that will definitely give you the force.
Yeah. It's a triangular one.
So that is again the area and this is. So that's how
So
it
this
works.
gives RA value of 90.15. You can check, sir, once calculated check.
Yeah. So how much you are getting?
90.18 or something.
90.18. So 0.5 into 55.5 into 1.5 into 1.5 plus 55.55 into 0.5 into 0.25, answer divided by 3. I am getting different value.
Sir, yours. Can you go back to the right side on second slide? Can you check the first thing, sir? No. Can you go to calculation spot? Okay. Try to see what is the P1 value you have written, sir. It is the UDL multiplied by triangular projection. Triangular projection is a 3 meter, right? You have written 1.5. Half into 55.5 into.
How much is 0.25 h?
Triangular projection. Triangular portion is a 3 meter, right? In the diagram.
Triangular portion should be
0.4
meter, right?
Sir?
Half into 55.5 and 0.25. So that is the 0.25 h. H is your 12 meter. So that is a 3 meter. Okay. So this is a 3 meter. Sorry. So this is 3 meter and it is acting at a distance half into 55.5 into 3 will give you this, and then you need to take the lever arm. So lever arm is available at a distance of 0.5, so it's 1.5, and again this is 55.5. So yeah, now how much we are getting? How much you are getting, ARV?
Reaction is 90.18. I got it, but still we need to check something here. P1 is correct only here. Into the centroid is 1.5 plus 1. 2.5 will come, sir. Centroid. Triangular portion centroid from the point B is.
It's 0.5
plus
1 by third
h by 3 of 3. It is 0.5 or 1.5, sir?
So
From point B. From point B,
from point B, so it's 3 meter. Okay, it's 4.5 meter. Sorry.
total is 4.5.
So total is 4.5 meters. So this is 0.25 is 3 meter. So look, let me check
A
here.
little bit read
Yeah.
diagram.
I'll draw with a different pen. So that is your. Okay. So this is the
Sir.
total height is your 4.5 meter, right? So this is your total height, which is 4.5
Okay.
till
Above the
start.
reaction A, it is a
So
1.5.
yeah, so 4.5 and your this diagram
Above the
is
above the strut is
is 3. So this is your 1.5, right?
yes, that is 1.5.
And then you are having
Yeah. Now what is happening is
this is
yeah,
happening. Yeah, so this is P1 where it's acting.
that is the location correct. Now we
So
can check
so this is basically
uh,
1.5 plus,
1.5.
yeah. So
Remaining
now
is okay.
this is 2.5, right?
Yes, sir.
So zero point 0.5 into 55.5 into 3 into 2.5 plus 55.55 into 0.5 into 0.25 divided by 3. So that is
Still any discounts? Any discomfort, sir?
let me see, 0.5 55.55 into 3.
So 55.5, there also small mistake is the check it. 55.5, after that it is 1.5 into 1.5 by 2, not zero point
Yeah,
0.5.
this one,
Both you
right?
can modify. Both, sir. That is a
Yeah.
1.5.
Okay.
Small
Let
error.
yeah, let's do this thing again. So here it's
Normally
here
diagram
itself.
we have to give more importance for this.
Yeah,
Calculation we get
I
easily, no
guess
problem.
no. So my bad is like I have considered this 0.25 as 4 meter, and then it
Yes.
made the whole mistake. This is the 3 meter which I need to take into account.
These examples normally
Yeah.
uh,
So
both the
that
sides we need to
so
focus.
that is 1.5 by 2, which is acting, and then the area is zero point 0.5. So 55.5 into
Uh,
zero point 0.5 is your
not no zero point 0.5 sir. That also 1.5. No?
that is also 1.5.
Hmm.
So
That's also
55.55 into 1.5 is your area, and
yes.
then we need to multiply it with the lever arm, which is available at a half distance, which is 1.5
Yes.
by 2, and then it's acting minus RA by 3. So ठीक है.
Now it is clear.
Hopefully, let's see such a silly mistakes. 55.55 into 1.5 into 1.5 divided by 2 divided by 3. Okay, Arvi, now I'm with you. So it's 90.26
180.
something. I'm getting.
It's okay, sir. No
So
problem.
it's
It's
kilonewton
kilonewton per
per
meter.
meter.
Yes, sir. Yes.
Now they are asking to calculate the load on strut A.
Yeah.
So
Then you have to multiply.
yeah, this is acting at a single line. So now since the if we see the location of the struts in the longitudinal direction means the direction in the like into the page if we see, so in longitudinally also you are having the placement of the strut. So for getting the force in each strut you need to multiply this value with the spacing. So
With the horizontal
reaction,
spacing.
yeah, reaction, oh sorry, I'll say the load in strut A is none other than 90.26 into 4.4. So which is your none other than 397.18 kilonewton. Okay,
Yes, sir.
so let's move to our next question, guys. Any doubt in this? I know we had made so many changes, but this is a simple mechanics based question. So you need to calculate the stress diagram. So stress diagram is already given to you, so you don't need to calculate that. Once you are having the stress diagram, you need to divide the stress diagram into different segments as the variation of the load. Once you have divided the stress diagram into different segments, you need to calculate the force by getting the area of that stress diagram for each individual segment. Then you need to calculate the lever arm for each segment, and by the simple mechanics, considering the moment about the hinge used to need to be zero, we'll take that particular we will take that particular boundary condition, and then you can calculate how to calculate the RA. So this is how the process goes. We have done so many mistakes in between, but yeah, this is the final simplified picture. So there's nothing like rocket science in that. So if you have any doubt, please feel free to ask, and if not so, then let's move to our next question. So this is the question number, okay, sorry, this is question number 10. I have written 9. So similarly, you need to calculate how much is the load available in stud B in kilometer. Guys, are you getting any answer? Might be there's some issue with the options available. So
Yes, sir. I have done it long back. The answer coming 702 kilonewtons.
okay, sorry. So like I think while copying the options, they repeated the same options. So the answer is 702.2 kilometer per meter. So let's see this. Anyone else got any other answer? So how did you solve, Ari?
So can you go back to the draw the free body diagram, sir, once again?
Yeah,
At, at, at B location, we have a two reactions.
hmm,
One is RB1, another one is RB2.
hmm,
So for the upper part already we got RA.
hmm.
Now we equate the forces. RA plus RB is equivalent to right hand side load,
Yeah,
from which we get RB1.
okay.
So from the same diagram we can find out right now RB1.
Yeah, so we'll draw this. So let's
Yeah.
follow what ARV is saying. So we are having this pressure diagram available with us. So you are having B strut available at this position, and then you are having C strut available at this position. So this B strut will basically be supporting some of the soil which is available above it and some of the soil which is available below it. So this strut B will be having the two components which it will be resisting. So first you are having RB1 plus RB2. So your RB1 is basically the soil which it's supporting from the for the soil
Upper,
above upper part, and for the
upper part.
RB2 is the soil which is supporting the below part. Similarly, your this part will be having RC1 plus
Yes, also.
RC2. So RC1 will be supporting some of the soil which is available above the strut C, and it will be supporting some of the soil which is available below the strut C. So we can utilize this particular concept to calculate how much total strut is coming in B. So we already know how to calculate the RB1. So calculation of RB1. So we have already calculated how much is the reaction in A. So this is a pressure diagram which was available. So
You can
this,
draw, sir, once again free
yeah,
body diagram only upper part.
yeah. So I'll draw this. So
Mm.
this was your this part, right?
Yes. Mm.
So here you are having the RB1. So you are having two struts available which are basically supporting this. So
Yes.
this is at this location you are having the RA, and at this location you are having the RB1. So your RA plus RB1 will be supporting whatever soil pressure diagram which is available. It's better I'll draw the arrow like this.
Yes.
This is the RA and this is the RB1, and your soil pressure diagram will look something like this. So we already know the pressure which you have calculated. So the P1 is your none other than half. So this is your 55.5, right? So half into 55.5, and the total height is how much?
3. Triangular height is 3 meter.
It's a 3 meter. And then you are having some part is rectangle, which is the total height available for that rectangle is 1.5, right?
Yes, sir. 1.5 into 55.5.
Sorry. So half into 55.5 into 3, then this part is your 55, sorry. So this part is your 55.5, and your this height is how much? It's 1.5, right?
That's all.
So that is your, this pressure diagram is corresponding to your, this force is corresponding to your triangular part, and this part is your rectangular part. So we already know what is RA. So your RB1 is basically, let me calculate this. So 0.5 into 55.5 into 3, 55.5 into 1.5, it's 166.5 minus RA is your 90.26, and this need to be, yeah, so this is your reaction B, like for per meter length. So this is 166.5 minus 90.26 will give you the 76.24 kilonewton per meter. So RB1 total will be your 76.24 into 4.4, right? How much it's coming? 4.4. So it's basically 335.456 kilonewtons. Now for calculation,
Second part.
yeah, so for calculation, come on, for calculation of RC1,
RB2, sir, not C.
sorry,
RB2.
calculation of RB2.
Then again draw the free body diagram, sir, for next part.
Yeah. So now you are having this part available with you. That
This is easy, rectangle.
rectangular part, right? Okay. So this is rectangular part. So here you are having the RB2, and then here you are having
RC1.
RC1, right? This
Yes,
is
sir.
your pressure diagram which is available. This length is 55.5
Kilopascal.
kilopascal. Here also I'll put kilopascal. The total height is
3 meter.
3 meter, right? So now it's simple. So some part is taken by RB2, some part is taken by RC1 for this pressure diagram. We are assuming that the both of the RB2 and RC1 are taking the equal loads. So RB2 plus RC1 is your half time 55.5 into how much is this? 3 meter, right? Yeah. So 0.5 into 55.5 into 3 is your 83.25 kilonewton per meter. So sorry, this is 55.5 into 3, this is 166.5, and also your RB2 equals to RC1 half time of 166.5. So divided by 2 is your 83.25 kilonewton per meter. So total RB2 is your 83.25 into 4.4 is your 366.3 kilonewton. So total force in B is your 335.456 plus 366.3 So how much you are getting yearly?
702, sir,
7 or 2.
approximately.
Have I made some mistake anywhere? So
Why,
it's
sir?
5583.25 into 4.44. It's
How much you are
366.
getting?
366. Yeah, so I think this 366 point. Yeah, it's 701. Yeah, so it's
Yes, 702.
7.756, which is, yeah, it's equivalent to 702 kilometer. So this is the answer. So guys, the final answer is 702 kilonewtons. So this is the total force which is being taken by strut B. Any doubt in this, guys? So I guess it's already 8. So I think we have completed the questions also. So if you have any other doubt, please feel free to ask. Otherwise we can call it a day. So those who will watch this video at a later stage, you can post your query in the comment section and we'll try to address your query. Otherwise we are done for the day. Guys, if you are having any doubt you want to discuss, or if you want to raise your query, so please feel free to ask. Meanwhile, like ARV, like, have you posted your query in the discussion forum? Did you get any feedback from them, or like any reply from them? Go ahead.
No, sir. No, 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 no.
Mm,
I have done the feedback,
acha,
but I
acha.
didn't get a response. It is only for the next course, not now.
Okay, 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 okay. So let's hope they'll consider your part.
Yes, sir. Yes,
Yeah.
sir.
Any other thing, Nishant, Vijay, anything else?
What is the next week, sir? Program? You have a
Uh,
last week. One more is there, right?
yeah, actually, I'm having two more classes.
Okay.
So they've asked, like, if you can, if you want to take one more class. So
Mm.
like, I'll go. I'll come with one more class. So maybe I'll explain something, mm, some another topic maybe related to your course, or I'll perform some numerical modeling if you guys are interested to see. Also, if you guys are interested in coding, like, I can also cover some part of the coding. So that one day I've asked for a extra schedule. So because in my previous NPTEL sessions, so a student have asked, like, they wanted to have a little background on the Python coding, so I have given some exposure on the Python coding, so I have utilized this session. uh, so maybe I'm not sure, like, I'll go with the Python, or I'll cover with some more sample questions related to that part. So we'll be having two more classes. So
Okay.
next class will be the week 12 session, and then the final class maybe, like, will cover some another topics maybe related to the course, or like uh, not related to the course.
Okay, sir. Thank you.
Yeah.
Good
Okay
night,
guys,
sir.
so I think we can call it a day. Thank you so much for joining.